I'll just quickly go over the nucleus for all of you. So the building blocks of everything that we see around us, all the matter, is called an atom. Okay? It's called an atom. It's derived from the Greek word atomos, which means indivisible. That's because the ancient Greeks had believed that you cannot separate an atom any further. It is the smallest unit of matter that you see around us.
It can be split into protons.
However, it's in recent centuries, it's been discovered that the atom is actually made up of even more particles, right? So the main three particles are the proton, the neutron, and the electron. Okay? The proton has a positive charge, the neutron has zero charge, and the electron has negative charge. So you can think about these charges like in a magnet, you have a north and south pole. Opposite ends attract, similar ends repel. Similarly, protons and protons repel, electrons and electrons repel, and the other two attract. Okay? So the nucleus, the atom itself is organized by a nucleus in the center, which houses the protons and neutrons, and then it has orbits around it, in which the electron orbits. Okay? So this is just a basic overview of the atom. There are many more complexities, and this is not an entirely accurate diagram based on our current understanding, but this is all you need to know for now. So what electricity is the flow of these electrons. What do I mean by the flow? Let's say you have a bunch of atoms side by side, okay? And each of these dots are the nuclei. So you have electrons here. Electricity is when this electron flows through all of these atoms. So the electron flowing is what electricity is. Any questions? Yes. Thank you very much. Do you have a question? Okay. So the flow of electrons from one atom to another is what we call as electricity. Okay? There are a few cases to this. Have you all heard of conductors and insulators?
Yeah, and semiconductors.
So what is a conductor versus an insulator? Yes.
A conductor conducts electricity, which means like electricity is usually like performs well on it, while the insulator electricity isn't as strong or doesn't.
Sure, that's one way of putting it. Yes.
A conductor conducts electricity, and insulators like repel electricity in a way.
So what does conduct electricity?
Like basically, it has less. I forgot.
It lets the electricity flow through, and the insulators do not let the electricity flow.
Yes, so basically what it is conductors, which most metals are conductors. So let's take copper for example. So copper, which is called Cu. In copper, if you have a bunch of atoms lined up, the electrons can easily flow through. Okay? However, if you have insulators, right? Insulators, like you can take rubber. I'm not sure of the atomic thing of rubber, so I'll just
Silicon?
write silicon, but it's some thing of silicon. So
Molecular, basically.
some compound with silicon and something that's not pure silicon. But let's say we take rubber, right? So rubber basically is an insulator because the electrons cannot flow smoothly. It like resists the flow of electrons. You can think of it as pushing the electrons back, right? And so what happens when the electrons are trying to go this way and this is pushing back? What does it create? Yes?
They go backwards.
It's not that strong that they go backwards. It can stop them, yes. But what else is created? Yes.
Electric charge.
Electric charge is the flow of electrons itself. But what happens when it's stopped by an insulator? Yes.
There's no electricity.
No electricity out. Yes.
Resistance.
Resistance, what does that all create? What does that generate?
Wait,
I'll give you a hint.
Heat.
Yes. Who said that? Okay. Yes. So that all generates heat, right? If you look at your hair dryer, right? How does your hair dryer work? None of you know? Yes.
So it produces a large amount of electric resistance, and then like when the electric charge and the resistance like kind of like fight against each other in a way. And then after that, it creates more heat, and that's how it like dries your hair.
Yeah, so basically how an hair dryer works is, right? So let's say you have, excuse my very poor drawing, but a hair dryer, basically you have this cable that you plug into an outlet over here, right? So what that does is, first of all you have a fan here, okay, that brings in air. Next, this electricity, there's a bunch of coils here, and these coils are made of an insulator. And so what happens when the electricity goes here, a bunch of heat is produced. And so when the air is taken in by the fan, it goes through the heat, gets heated up and is released. And so that's just a basic relevant example of how we use insulators versus conductors in our daily lives. If you look at any regular wire, right, phone cable or anything, it has a copper wire inside that conducts electricity, and around it, it has an insulator, which is usually plastic or rubber, so that you don't get shocked, right? So the electricity flows freely inside, and outside, if you're trying to touch it, you don't get shocked because the insulator prevents the electricity from coming out. Wonderful. Now there are 3 terms that you have to know in regards to electricity. These are voltage, current, and resistance.
Don't they all have like some relation amongst each other?
Yes, they do. They're all similar. Do any of you know what each of them mean? Yes.
voltage is the amount of electrons going through.
No.
I think it's like
Watts, I think.
it's like some
Yes.
the amount of energy in like divide the amount of energy in like energy like the amount of energy in some area divided by the charge of something.
Close. Yes.
I think voltage is like ampere, like something.
I think it's a term that you can use to describe like units of energy.
Close. Yes.
The amount of electricity that is getting produced.
All of those are very close, and these 3 terms, especially these 2, voltage and current, can be very confusing to understand. So let me go through them, right? Voltage is measured in volts, or V for short, and each volt is joules per coulomb. Oh, what does that even mean, right? This basically says joules is a unit of energy. So how much energy something has, how much energy it can give, how much work it can do, right? And coulombs is used to measure a certain amount of electrons. Okay, it translates to approximately 2.34 times 10 to the power of 12. I might be missing a few zeros here and there.
Where?
Electrons. Okay, so each coulomb has like 2,340,000 billion electrons, and so it's basically saying how much energy does each packet of those electrons carry, and that's the voltage. So you can think of it as voltage is what is pushing each current, the electricity flow forward. Yes.
Can you explain the word again?
Yes. So think of each electron, instead of looking at each electron individually, what Coulomb is basically doing is taking a bunch of them and putting it into one packet. So 1 Coulomb has a few hundred billion amount of electrons inside. Okay? So that's basically a unit of measuring electrons. So we don't have to say that there is 10 joules per 20 billion trillion electrons. You can say there's 10 joules per like 20 Coulomb electrons. Yes.
So are multiple coulombs inside one electron?
No. A Coulomb is made up of an n number of electrons.
So is an atom bigger or a coulomb?
A Coulomb is just a unit. It's just a unit of measurement. It's not a particle itself. Okay. So we just group them for easier numbers. So instead of having to do 0.000000, we can just say 2.
Quick question, are these all scalar or vector quantities, these voltage, current, and resistance?
I'm actually not sure on that. I believe that voltage will probably be a vector quantity, but I'll check and get back to you. Okay? So voltage is measured in joules per coulomb, and it basically says a Coulomb number of electrons, how much energy does it have? So joules per coulomb, energy per this number of electrons.
Oh, so it's like basically energy, how much energy is needed to push like a current? Like,
How much energy a current is bringing with it.
oh,
So you can think of it as volts is what is like is a watt. This is the easiest analogy for this. Think of your water faucet at home. Okay, volts is the pressure of the water. Have you ever had a high pressure hose or something? The higher pressure the water comes in, the faster it comes out, right? The lower pressure, the slower it is. You can like opening your tap, you're getting more water versus less water. That's basically what voltage is doing. Voltage is increasing the energy and the push that's on the electric current, so it goes faster, higher pressure. Okay? Next we come to current. Current is measured in what we call amperes. Or amps for short. Okay, so current is basically how much water is there, how much water is getting flowed. So, and what's the speed of that water?
this is like per time or something?
So current is measured in coulombs per second. So how many electrons are passing by a certain point every second? Like we say miles per hour, right? The speed of a car. The speed of the electrons as they're flowing is measured in amps or coulombs per second. Okay? And lastly, we have resistance. We talked about resistance. It's how much force is pushing back on the electron. You can think of it as each pipe that the water is flowing through getting smaller, which means a smaller number of electrons can flow through. And so resistance is measured in what we call ohms, or we use a Greek letter omega for that.
Doesn't ampere also have a letter for it to represent it?
Yes,
I think it's an A, mainly.
yeah. It should be an A. I'm not completely sure if there's like an A and P, but you can just put A for it. Okay? So voltage, current, resistance. Any questions? Do you all understand? Yes.
Wait, so what exactly is volts? If you do, so without the joules over coulombs, what exactly is voltage?
It is the amount of energy that an electron brings. So if you have let's say more energy packed in, let's say a stronger battery, right? Then your voltage will increase. Does that answer your question? So it's the amount of energy per electron, and that energy determines how the flow of the electrons is like. Okay? So let's do a quick practice problem. Okay, let's say that you have 20 joules are flowing through a certain current, and when that 20 joules pass, you have 5 coulombs of electrons that pass in 3 seconds. So give me the voltage and current at this place. Yes. No? Give me one.
The volts, is it 5? No, is it 4 volts?
Yes, it is 4 volts because volts is joules per second, 20 by 5 is 4. You want to give me current?
Yeah, it's 5 by 3 amperes.
Yes, 5 by 3 amperes, coulombs per second. Do you all understand? Any questions? Beautiful. Now that we've gone through these, let's talk about how we create electrical circuits with this. Okay? So there are 2 types of electrical circuits. First one is called series, and the next one is called parallel. You have series and parallel circuits. In series circuits, you have an electrical source, let's say a battery, okay? Then it is connected by a wire to whatever you want. Let's say this is like a light bulb or a motor or speaker, whatever you want it to be. And it's connected back. So, you will have all of whatever you want to connect on the same line like this in a series. So can anyone think of a common everyday example of where they've seen a circuit like this, where you just have one line with everything on it? Yes?
Like the string lights.
Yes, precisely, that's the most common example. So string lights, right? So in a string light, you connect power source to one end, and on one line you have every single light attached. But here there's a problem with series circuits, right? The problem with series circuits is that your electricity flows from positive to negative end, right? And it depends on this one line. So what happens if this light, let's say all these are shining right now, what happens if this one light stops shining and it says, no, I'm not working anymore? Yes,
The whole thing will stop.
precisely. After this, no more electricity can flow, and so both of these will stop working too. So that's one of the problems with series circuits, that you don't have redundancy, or you don't have checks for errors. If you have an error in one, then the rest of them are all gone.
Is this different in parallels?
Yes, we'll get to that. So here, what it is that that's why in your string lights, right? Usually they'll have 3 different wires wrapped around each other, and so you have 3 separate strings of the lights. So that even if one string fails, you still have 2. So most of your lights are still on. So now, parallel circuits. Can anybody think of a way to fix this problem? Yes.
Like add an extra wire in between 2 of them, so like
Add an
skip
extra
some
wire
of
in
them.
between 2 of them. So you mean like if we go here, you want 2 wires here.
No, that's not what I meant.
Okay then, how would you say?
Like if there's like 5 light bulbs, like instead of like doing one string, like you can also add a separate connection between like light bulb 1 and light bulb 5, like 2 connections.
Oh, so
Like you skip.
like this.
Yeah.
Okay, but what happens if this light bulb fails?
The rest all fail.
Yeah.
Isn't this like an example of short circuit? You'll use the shorter path. The current will flow in the shorter
Yeah.
path.
It will.
All light only serves to find the fastest.
To solve the problem, you can just give each light bulb its own individual connection.
And
Exactly.
you can
So that is exactly what the parallel circuit does. Okay. So if you have a parallel circuit like this, what happens is each light bulb is on its own rung, like this. And so even if this one fails, each of them still get electricity on their own separate channels, right?
Wait, but I'm not still short circuit.
And so this is what a parallel circuit is, and it fixes the problem that we see in series circuits. But what is a problem that you can think of in these circuits? Yes.
Short circuit.
What is a short circuit?
It's when light tries to find the fastest way to get to its destination.
Sure, but let's. Can you explain short circuit?
It's basically like which the electrons will choose which path is the shortest to get to the negative side. So in this case, it will be the first one, this first light bulb that will light up, and everything else will fail.
They won't all fail. This one will shine the brightest,
Oh,
and this one will be slightly less. This one will be slightly less. And that's the problem with parallel circuits, is that you're dividing up your current between all of these. So now let's talk about current, voltage, and resistance in series and parallel circuits. Okay? So let's say we have the battery source here. We have 1, and we have 2, and we connect it back. And similarly here, we have 1, and we have 2. Okay? So in this case, the total voltage for this entire circuit, let me just go like that. The total voltage for this entire circuit is going to be the voltage experienced by 1 plus the voltage experienced by 2. So we have instruments that can measure all of these that you can add to your circuit. This is just for common mathematical concepts if you want to deduce one of these given data values. The total amperes is equal to the current experienced by 1 is equal to the current experienced by 2. Okay? Because the flow of the electricity is the same throughout. And the resistance is again equal to resistance by 1 plus resistance by 2 is the total resistance for it to travel, electricity to travel through it. Now if we come to parallel circuits, the total voltage of 1 is equal to the total voltage of 2 is equal to total voltage, because the power which the electrons are coming are the same no matter where it is in. However, the current gets divided up. So the current is equal to A1 plus A2. And the resistance is a little weird in this case, is equal to 1 over R1 plus 1 over R2 is equal to 1 over the total resistance. Okay, so the total resistance of a parallel circuit has to be less than the resistance experienced by either 1 or 2. Okay, so R is less than R1 and R is less than R2. Okay, so this is a rule for resistance in parallel circuits. If that's not the case, then you've done your calculations wrong. Any questions? No? Wonderful. So let's say that in this parallel circuit, one experiences a resistance of 5.0 ohms and 2 experiences a resistance of 10.0 ohms. Can you tell me the total resistance experience in the parallel circuit?
Total?
The total resistance is created in the parallel circuit. Anyone else? Yes.
Is it 3 tenths? Because if we're doing 1,
1 over r is 3 tenths, so what is r?
so the first r is 5, the second is 10, right?
Yeah, so you're doing 1 over 5 plus 1 over 10, which is 1 over r. So 3 by 10 is 1 over r. So r is, if you have 1 over r is equal to 3 by 10, what do? You just swap the two. So r is equal to 10 by 3. Is equal to approximately 3.3 ohms. Any questions? Yes.
For the resistance of a parallel circuit, if 1 over r equals 1 over r1 plus 1 over r2, wouldn't that be the same as r1 plus r2?
No, that's not how.
If you were to do some math? Who's in? I don't know. Okay, so if you have 1 over r, let's keep this value as a and this value as b, okay? Equal to 1 over a plus 1 over b. If you wanted to switch it around, then it would be 1 is equal to ab is equal to rb plus ra. And so r of a plus b is equal to ab. So r is equal to ab by a plus b. It is not a plus b, it is ab by a plus b. So if you wanted resistance in this case, then you can also write resistance is equal to R1 times R2 over R1 plus R2. Let's see if I did my math right. So what is R1 times R2
For
in this case?
50.
50. What's R1 plus R2?
15.
50 over 15 is 10 over 3, which is 3.3. Right?
Are you using significant digits here?
Huh?
Are you using this?
Yes.
Can you say
What
that
is
again?
that R times A what? What's that significant?
Which one? This? So we have RB plus RA, right? So I just take the R out of it. So it's R, distributive property of addition. R times B plus A or A plus B. And then you just take this entire thing and divide it on both sides. So you get R is equal to AB by A plus B. So R is equal to R1, R2 over R1 plus R2. That's the way you would write it. Not R is equal to R1 plus R2. Yes.
What happens if you have multiple, like multiple components in like a series or parallel? What is the total resistance there?
You keep on going as
Oh.
long as you want. And all that will do is just add here. No change. You just keep on adding to it.
Yeah, let me answer it.
Same with any of these.
What
Right?
about the series?
Just add. Plus R3, plus R4, plus V3, plus V4, plus A3, plus A4.
Oh, okay.
Just the total is just the sum of the components. What I'm going to be doing, I want you all to create series circuit and parallel circuit. I will be giving each of the groups battery cases, okay?
I can give myself one of those.
what is the red side? Positive or negative?
Negative.
Positive.
It's positive. The black side is negative. If you switch them up, it will blow up these holes.
Okay.
I think it will just heat up. I think.
Okay? So, red side positive, black side negative. Okay? This here is a motor. If you connect it, this thing will spin. You can hear it spinning.
DC, is it a DC motor?
Yes. We do not have a fan to put on here for now, but you can hear it spinning. Make sure you connect one end positive, one end negative. It does not matter which end in this case.
Oh, that's
However, in this case, does it matter which end you connect it to?
Yes.
Which side is positive?
Red.
Which side is negative?
Black.
Wonderful. And with these LED lights, does it matter which side you connect it to?
Yes.
Which side is positive?
Longer.
Longer side. Which side is negative?
This
Shorter
shorter
side. Please
I
do
know
not.
what's happening.
I can't see which side's longer. Look at it closely.
It's barely longer. So please do not short circuit and break any of my components. Thank you very much. Each group, what are these called?
Jumper wires.
Alligator clips.
Alligator clips. Each group will be getting 4 alligator clips, and you all can do whatever you want and have fun.
Trying to get the DC
Okay.
motor to spin.
Let me do this.
You can use the motor, you can use the speaker, you can use the lights. What I want you to do is make a series circuit and make a parallel circuit.
Let's try to short circuit.